On the morning of March the 17th, 1943, diplom engineer Friedrich Hasselmann walked slowly around a captured M4 Sherman tank and permitted himself a thin smile of professional contempt. The tank sat in the examination bay of the Heereswaffenamt proving ground at Kummersdorf, 30 kilometers south of Berlin. It had been captured intact in Tunisia 3 weeks earlier, one of the first Shermans to fall into German hands, and shipped to Germany with the urgency usually reserved for secret weapons. Senior officers of the Wehrmacht's Technical Intelligence Branch had gathered to witness the dissection. They expected to find American secrets worth stealing. Hasselmann, chief of armored vehicle analysis for the Waffenamt, expected to find nothing of the sort. He ran his hand along the Sherman's hull, feeling the welded seams, noting the bolted-on applique armor plates that American crews had added in a futile attempt to improve protection. He rapped his knuckles against the front glacis. 51 millimeters of cast steel, set at an angle that provided perhaps 60 millimeters of effective thickness. His own nation's Panzer IV carried 80 millimeters. The new Panther, just entering production, carried 80 millimeters sloped at 55 degrees, yielding an effective thickness exceeding 120 millimeters. Inadequate, Hasselmann murmured, loud enough for his assistant to record in the inspection log. He climbed onto the hull, lowered himself through the commander's hatch, and spent 20 minutes examining the interior. The turret cramped him. He was a tall man, but he noted with grudging approval that the crew stations were reasonably well arranged. The gun breech dominated the fighting compartment, a 75mm M3 cannon, American-made, with a vertical sliding block mechanism. He examined the ammunition storage, the radio equipment, the periscopes, and vision blocks. When he emerged, the assembled officers watched him expectantly. "Gentlemen," Hasselmann announced, brushing dust from his uniform, "we have nothing to fear from this vehicle." He gestured at the Sherman with something approaching pity. "The armor is insufficient to resist our 75mm tank guns at any combat range. The 50mm KWK will penetrate it at 800 meters. The short 75 will penetrate it at over a kilometer. Against our new long 75, he shrugged. It is a death sentence for any crew foolish enough to face us." He moved to the front of the tank, pointing at the hull. "The gun is equally inadequate. The American 75mm cannot penetrate the frontal armor of a Panzer IV at ranges beyond 500 meters. Against a Panther or Tiger, it is essentially useless. The Americans will be forced to close to suicidal range to achieve kills, assuming they survive long enough to close at all." Oberst Werner Kruger, representing the Inspector General of Panzer Troops, nodded with satisfaction. "And the automotive components? The engine, transmission, running gear?" Hasselmann's smile returned. "Crude. The engine is a modified aircraft radial. Adequate power, but wasteful of fuel and maintenance intensive. The transmission is a simple synchromesh design, nothing innovative. The suspension is a vertical volute spring system, decades old in concept. Every component suggests a vehicle designed by men who have never built a serious tank before." He paused, ensuring his conclusion would be properly recorded. "This vehicle represents the American philosophy of warfare, quantity over quality, mass production over engineering excellence. They have built a tank that can be manufactured by the thousands in automobile factories. They have sacrificed armor, armament, and sophistication for ease of production. It is, in summary, a mediocre vehicle designed by industrial engineers rather than weapons engineers." The officers exchanged satisfied glances. This was what they had hoped to hear. "My recommendation," Hasselmann concluded, "is that we file a complete technical report and take no further action. The Sherman poses no threat that requires a response. Our existing vehicles are superior in every meaningful metric. The Americans have built a tank for a war of logistics. We will show them that wars are won by superior weapons, not superior factories." The report Hasselmann filed, Document Wayproof 1/3-487/43, ran to 47 pages of detailed technical analysis. It cataloged every dimension, every alloy composition, every mechanical tolerance of the M4 Sherman. It was thorough, professional, and meticulous. It was also catastrophically wrong, not in its measurements. The armor thickness was exactly as Hasselmann recorded. The gun performance was precisely as he calculated. Every technical specification in those 47 pages was accurate to the millimeter. But Hasselmann had measured the wrong things. He had measured armor and found it thin. He had measured the gun and found it weak. He had measured the engine and found it crude. What he had not measured, what he lacked the framework to even consider measuring, was the Sherman's true genius, its standardization, its replaceability, its design not for the battle but for the war. The Germans had built tanks to win engagements. The Americans had built tanks to win something else entirely. And by the time German engineers understood what they had missed, the Shermans would be coming in numbers that no thickness of armor could stop. To understand why German engineers evaluated the Sherman as they did, one must first understand how Germany had come to think about tanks. The German approach to armored vehicle design was rooted in a single elegant principle, Waffenwirkung, weapon effect. A tank existed to deliver firepower to the enemy while protecting its crew from enemy firepower. Every design decision flowed from this calculus: armor thick enough to survive enemy guns, guns powerful enough to defeat enemy armor, at ranges that favored the better protected, better armed vehicle. This was not theory, it was doctrine forged in combat. In Poland, German tanks had faced Polish 7 TP light tanks and destroyed them at will. In France, they had encountered the Char B1 and Somua S-35, vehicles with armor thick enough to resist German guns, and had learned painful lessons that drove immediate design improvements. On the Eastern Front, the appearance of the Soviet T-34 and KV-1 had triggered a crisis that reshaped German tank development entirely. The T-34 in particular had shocked German engineers. Its sloped armor, powerful gun, and wide tracks represented a design philosophy that German intelligence had completely failed to anticipate. General Oberst Heinz Guderian himself had recommended simply copying the T-34 wholesale, a suggestion rejected on grounds of national pride, but one that revealed how seriously German designers took the threat. The response had been the Panther, 45 tons of engineering excellence with sloped armor derived from T-34 principles, a high-velocity 75mm gun capable of defeating any Allied tank at extreme range, and a sophisticated torsion bar suspension. The Tiger, already in production, offered even heavier armor and the devastating 88mm gun. Together, these vehicles represented the pinnacle of tank design, weapons optimized for the single metric that German doctrine held supreme: the ability to destroy enemy tanks while surviving enemy fire. By 1943, German tank designers operated within a framework that seemed irrefutable. Hauptmann Ernst Berger, a technical intelligence officer attached to the Waffenamt, articulated this framework in a lecture to junior engineers in February 1943, 1 month before Hasselmann's examination of the captured Sherman. The tank is a weapons platform. Its value is measured by 3 factors: firepower, protection, and mobility, in that order. Firepower determines whether you can kill the enemy. Protection determines whether you survive his attempt to kill you. Mobility determines whether you can bring your firepower to bear. A tank that excels in firepower and protection but lacks mobility is a defensive weapon. A tank that excels in mobility but lacks firepower and protection is a reconnaissance vehicle. A tank that excels in all 3 is a battle winner. He had drawn a triangle on the blackboard, labeling each vertex. The Americans, we are told, have built a tank called the Sherman. Intelligence reports suggest it is mechanically reliable and produced in large numbers. But examine the triangle. Its firepower is inferior to our Panzer IV, vastly inferior to our Panther and Tiger. Its protection is inadequate against any of our tank guns. Its mobility appears acceptable, but not exceptional. By every metric that matters, it is an inferior vehicle. Numbers cannot compensate for this inferiority. 100 Shermans facing 10 Panthers will lose 90 Shermans before destroying a single Panther. This is mathematics. The mathematics felt irrefutable because German experience seemed to confirm them. In North Africa, Tiger tanks of Schwerpanzerabteilung 501 had achieved kill ratios exceeding 8-to-1 against British and American armor. At Kursk, German tanks had destroyed Soviet armor at rates that should have been strategically decisive. Over 6,000 Soviet tanks lost in a single campaign. The Panther, despite mechanical teething troubles, was demonstrating in combat that it could engage and destroy enemy tanks at ranges where they could not effectively respond. Oberst Wilhelm von Thoma, captured at El Alamein and later interrogated by British intelligence, had offered an assessment that German planners found reassuring. The British tanks are coffins. The American tanks appear to be the same. They burn when hit. They cannot penetrate our armor. If this is what the Western Allies intend to use against us in Europe, I do not fear the invasion. The institutional confidence ran deep. Professor Ferdinand Porsche, whose engineering bureau competed with Henschel for German tank contracts, dismissed American tank design in characteristically blunt terms during a 1943 meeting with Albert Speer. The Americans build automobiles, they know nothing of armored warfare. Their Sherman is a Ford with a cannon, mass-produced, standardized, and worthless against serious opposition. They will learn at great cost in lives that war cannot be won on an assembly line. Even those German engineers who respected American industrial capacity believed it was being misapplied. Diplom-Ingenieur Heinrich Kniepkamp, chief of the Waffenamt's automotive design section, wrote in a technical memorandum dated April 1943, "American industrial production is formidable but misdirected. They have chosen to produce large quantities of an adequate design rather than smaller quantities of an excellent design. This is a strategic error. In armored warfare, quality defeats quantity because a superior tank can destroy multiple inferior tanks before being destroyed itself. The Americans are building targets, not weapons. Their factories work against them. Every Sherman produced is a crew that will die, resources that will be wasted, a battle that will be lost." Kniepkamp's memorandum was circulated approvingly through Wehrmacht technical channels. It confirmed what German engineers already believed, that their approach to tank design was correct, that American mass production represented a fundamental misunderstanding of armored warfare, and that the coming battles would vindicate German engineering philosophy. The logic was internally consistent. The evidence seemed to support it. The mathematics appeared incontrovertible. But the German framework contained a flaw so fundamental that no one within the system could see it. German engineers evaluated tanks as weapons. They measured armor penetration, muzzle velocity, protection levels, the metrics of combat between individual vehicles. They asked, which tank wins when two tanks meet on a battlefield? They did not ask, which tank wins when one tank is destroyed and must be replaced? They did not ask, which tank wins when an engine fails 50 kilometers from the front? They did not ask, which tank wins when a transmission breaks and spare parts must be manufactured, shipped, and installed? They measured the Sherman against the Panther and found the Sherman inferior. What they failed to measure was the Sherman against the war, the long, grinding, attritional war that would be fought not in single engagements but across months and years, not between individual tanks but between industrial systems, not for tactical victories but for strategic exhaustion. The answers to the questions they didn't ask would have terrified them, but they didn't ask. And so they concluded, with the confidence of men who believed they understood warfare, that the Sherman was a mediocre tank built by engineers who didn't know any better. They were about to discover what those engineers actually knew. In the spring of 1941, a 53-year-old mechanical engineer named Gladian Marcus Barnes sat in his office at the Rock Island Arsenal and contemplated a problem that had nothing to do with killing Germans. Barnes was the chief of the Tank Automotive Center's design division, a bureaucratic title that concealed an extraordinary responsibility. He was the man charged with designing the tank that would carry American soldiers into a war that everyone could see coming. He had studied the German campaigns in Poland and France. He had read the intelligence reports on the Panzer III and Panzer IV. He understood, with the clarity of an engineer who had spent 30 years solving practical problems, exactly what America needed. And it was not the best tank in the world. "We cannot build the best tank," Barnes told his design team in a meeting dated April 14, 1941. "We do not have the experience. We do not have the industrial infrastructure optimized for tank production. We do not have the time to develop both. The Germans have been refining their designs for a decade. We are starting from nearly zero." He spread blueprints across the conference table. Drawings of the M3 Lee, the stopgap medium tank then entering production, with its awkward sponson-mounted 75mm gun and tall, vulnerable profile. "This is what we have. It is not good enough. But the question is not whether we can build something better than this. The question is, what kind of better can we achieve in 18 months, with the factories we have, using the workers we can train, to fight a war we do not yet fully understand?" Barnes had studied the German approach and rejected it, not because it was wrong, but because it was inaccessible. Germany's tank designs emerged from a sophisticated military-industrial ecosystem that had been developing since the Treaty of Versailles. Their engineers had decades of experience. Their factories were purpose-built for precision manufacturing. Their crews were trained professionals who could coax performance from temperamental machinery. America had none of this. What America had was automobile factories, assembly lines, workers who knew how to build Fords and Chevrolets and Chryslers by the million, a logistics system designed to ship consumer goods across a continent, a maintenance culture built around standardized parts and replaceable components and repairs performed by ordinary mechanics rather than specialized technicians. Barnes understood that this was not a weakness to be overcome, it was a strength to be exploited. "We will not try to build a German tank," he declared. "We will build an American tank, a tank that can be manufactured in automobile factories by workers who have never seen a tank before, a tank that can be maintained in the field by mechanics trained on Chevrolet trucks, a tank that can be shipped across an ocean in pieces and reassembled at the other end, a tank that can be replaced, not in months, but in days." The design specifications Barnes established for what would become the M4 Sherman reflected this philosophy in every detail. The hull would be welded or cast, not the complex machined assemblies of German tanks, but simple shapes that could be produced by shipyards and locomotive factories retooled for war production. Multiple manufacturing methods were deliberately designed into the specifications, allowing different plants to use different techniques based on their existing capabilities. The engine presented a particular challenge. America had no proven tank engine in production, no time to develop one from scratch. Barnes's solution was radical: design the tank to accept multiple different power plants. The Sherman would eventually be produced with 5 different engines: the Continental R975 radial, the General Motors 604-6 twin diesel, the Ford GAAV8, the Chrysler F57 multibank, and the Caterpillar D200A diesel. Each required slightly different engine compartment configurations. Each could be installed based on what was available. No single engine shortage could halt production. The Germans would consider this insane, Barnes noted in a design review. Multiple engines mean multiple spare parts inventories, multiple training programs, multiple maintenance procedures. But the Germans have one automotive industry. We have a dozen. Let General Motors build what General Motors knows. Let Chrysler build what Chrysler knows. Let Ford build what Ford knows. We will make them all work. The transmission was a commercial synchromesh design, adapted from heavy trucks. It lacked the sophistication of German tank transmissions, but it could be manufactured by dozens of factories already producing similar components, and it could be repaired by any mechanic who had worked on American trucks. The suspension was a vertical volute spring system, a design dating to the 1930s. German engineers examining captured Shermans would note correctly that it was primitive compared to their own torsion bar systems. What they would not note, because it did not fit their evaluation framework, was that the VVSS suspension used bolt-on components that could be replaced in the field without specialized equipment. A Sherman that threw a bogey wheel could be repaired in hours. A Panther that damaged its torsion bar suspension required depot-level maintenance. Every decision Barnes made optimized for the same hidden variable: time to return to combat. The gun mantelet used a simple curved casting that could be produced by any foundry. The driver's hatches were designed for rapid escape. Crew survival meant experienced crews returned to new tanks rather than being replaced by novices. The engine deck could be removed in its entirety for power plant replacement, a procedure designed to take 4 hours in the field versus days for German tanks. Major William Duncan, an ordnance officer who served as Barnes's liaison to the Army ground forces, questioned whether these compromises would produce a competitive vehicle. The intelligence reports say the Germans are developing heavier tanks, Duncan warned in a June 1941 memorandum. If we optimize for production and maintenance, we may field tanks that cannot survive combat. Dead crews and destroyed tanks help no one. Barnes's response, preserved in the project files, revealed the depth of his strategic thinking. "You are measuring the wrong thing, Bill. You are asking whether our tank can defeat their tank in single combat. That is the wrong question. The right question is whether our tank force can defeat their tank force over the duration of the war. A tank that wins every engagement but breaks down after 500 miles is worthless in a war fought across continents. A tank that loses some engagements but keeps running, keeps getting repaired, keeps coming back, that tank wins wars." He leaned forward, tapping the blueprints. "The Germans will kill our tanks. I accept this. They have better guns, better armor, better crews, for now. but we will replace our tanks faster than they can kill them. We will repair our tanks faster than they can damage them. We will put more tanks in the field every month while they struggle to maintain what they have. This is not a boxing match, Bill. This is a siege. And in a siege, the side that can outlast the other wins. The M4 Sherman entered production in February 1942. Within 6 months, American factories were producing 1,000 tanks per month. Within a year, production exceeded 2,000 per month. By 1944, the arsenal of democracy was building Shermans at a rate of over 1,500 per month. A flood of armored vehicles that would have been physically impossible had Barnes optimized for combat performance rather than manufacturability. The Germans, examining their captured Sherman at Kummersdorf, measured armor thickness and gun caliber and engine horsepower. They found a vehicle inferior by every metric they considered meaningful. They did not measure time to manufacture. They did not measure interchangeability of parts. They did not measure field repairability. They did not measure crew escape rates or component standardization or the ability to accept multiple engine types from multiple factories. They did not measure these things because their framework had no place for them. In German doctrine, these were logistics concerns, important perhaps, but secondary to the primary question of combat effectiveness. Glady and Barnes had designed a tank around a different question entirely, not, can this tank kill a Panther, but, can this tank system, the tanks, the crews, the factories, the spare parts, the repair depots, the replacement pipeline, sustain a war of attrition against an enemy fighting on the other side of an ocean? The answer to the first question was, not reliably. The answer to the second question was, yes, indefinitely. The Germans had measured the Sherman's weaknesses with perfect accuracy. They had entirely missed its strength. The first Shermans met the Wehrmacht in the deserts of North Africa, and they died exactly as German engineers had predicted. October 23, 1942. El Alamein. The British 8th Army launched Operation Lightfoot with over 1,000 tanks, including 252 newly arrived M4 Shermans, the first significant deployment of American medium armor in the war. The Shermans were greeted with relief by British tank crews who had suffered through years of undergunned, under-armored cruiser tanks. Finally, they believed they had a vehicle that could stand against German armor. The belief survived approximately 48 hours. On the second day of the offensive, B Squadron of the Nottinghamshire Yeomanry advanced into a screen of concealed 88mm guns and Panzer IVs near Kidney Ridge. In 11 minutes, the squadron lost 14 of its 17 Shermans. Survivors reported that German rounds penetrated their frontal armor at ranges exceeding 1,500 meters, distances at which their own 75mm guns could barely identify targets, let alone engage them effectively. They blew up beautifully. Feldwebel Hermann Eckhart of the 21st Panzer Division wrote in a letter home, "One hit, and they burn. The crews rarely escape. We call them Tommy Coker, Tommy Cookers." The British seem to have acquired American equipment and American luck, which is to say, none at all. The nickname spread through Africa Corps units with the black humor of men who dealt in death. Tommy Coker. Other variants emerged: Brennendus Grab, Burning Grave, Sardinenbüchse, Sardine Tin, and the most enduring, Ronson, after the American cigarette lighter whose advertising slogan promised it, "lights every time." The mockery was grounded in technical reality. The Sherman's ammunition storage, positioned in sponson racks along the hull sides, was vulnerable to penetration. When a round pierced the armor, it often ignited the propellant charges, and the resulting fire gave crews seconds, sometimes less, to escape. Early Shermans lacked wet stowage systems that would later reduce this vulnerability. They burned, and their crews burned with them. British assessments, filtered through channels that reached German intelligence, confirmed the Shermans' deficiencies. Major General Raymond Briggs, commanding the 1st Armored Division at El Alamein, wrote a scathing evaluation in November 1942. The M4 Sherman represents a modest improvement over our cruiser tanks, but falls far short of parity with German armor. Its 75mm gun lacks the velocity to penetrate Panzer IV frontal armor reliably at combat ranges. Against the Tiger, recently identified in theater, it is essentially helpless. The vehicle's height makes it conspicuous and difficult to conceal. The tendency to catch fire when penetrated has severely impacted crew morale. Briggs's report circulated through Commonwealth and American commands, generating alarm and recrimination. It also found its way through intelligence intercepts and captured documents. to German analysts who incorporated it into their assessments with evident satisfaction. Even the British, our primary opponents in this theater, recognized the Shermans' inadequacy, noted Hauptmann Ernst Berger in an intelligence summary dated December 1942. Their own evaluations confirm our technical analysis. The Americans have produced a vehicle optimized for mass production at the expense of combat effectiveness. This is the choice of a nation that does not understand armored warfare. Kasserine Pass, in February 1943, seemed to provide final proof. The American Second Corps, blooded for the first time against German armor, lost 183 tanks in 3 days of chaotic fighting, many of them Shermans, knocked out by German 75mm and 88mm guns at ranges where American crews could barely see their killers. Tank battalions that had trained for months in the California desert discovered that nothing had prepared them for the speed and violence of German armored tactics. First Lieutenant James Caldwell, commanding a Sherman platoon of the 1st Armored Division's Company C, survived Kasserine and provided an after-action report that captured American despair. We couldn't touch them. We fired at ranges of 800 yards and watched our rounds bounce off. They fired at 1,500 yards and went through us like paper. My platoon lost 3 of 4 tanks in less than 2 minutes. I saw Sergeant Morrison's tank take a hit and just erupt. The whole turret lifted off. There was nothing left to recover. The Germans aren't fighting the same war we are. They have weapons we can't match. German analysts incorporated Kasserine into their assessments with something approaching finality. American tank crews have now experienced the reality of armored combat against a professional opponent. Oberst Alexis von Roena wrote in a March 1943 intelligence summary, "The results confirm technical assessments. The Sherman is inadequate in firepower and protection, and American crews lack the training and tactical sophistication to compensate. While American industrial capacity remains formidable, production of inferior vehicles in large numbers does not constitute a path to victory. We may expect continued American tank losses at rates of 3-1 or 4-1 against our formations." The confidence was institutional, comprehensive, and documented in reports that circulated from the Waffenamt to the General Staff to Hitler's headquarters. Back in Germany, Diplom Engineer Hasselmann received reports from North Africa with grim satisfaction. The captured Sherman he had examined at Kummersdorf was performing in combat exactly as his analysis had predicted. His 47-page report was being validated, one burning tank at a time. The American vehicle confirms all assessments, Hasselmann wrote in an addendum to his original report dated March 1943. Combat reports indicate vulnerability to all German anti-tank weapons at standard engagement ranges. Crew casualties are severe due to fire risk. No design modifications have been observed that would alter the fundamental inadequacy of the vehicle. Recommendation remains unchanged. No responsive action required. Even American observers struggled to defend the Sherman's combat record. Brigadier General George Patton, not yet commanding an army but serving as an observer in Tunisia, wrote to General George Marshall with characteristic bluntness, "Our tanks are outclassed. The Sherman cannot fight a Panzer IV on equal terms and is helpless against the Tiger. We are asking American boys to go into battle with the second best weapon and expecting them to win through courage alone. Courage is not a substitute for inches of armor. We need a better tank, or we need to accept that we will trade lives for real estate at a rate no democracy can sustain." The pressure for a heavier, better-armed tank intensified throughout 1943. Programs accelerated. Prototypes were built and tested. The T-20 series, the T-23, the T-25, the T-26, designs that would eventually yield the M26 Pershing, a tank that could genuinely match German armor. But the Pershing would not reach combat in significant numbers until the final weeks of the war. For the campaigns that mattered, Normandy, the Breakout, the race across France, the Ardennes, the Sherman would remain America's primary tank. The mediocre vehicle that German engineers had dismissed would carry the burden of the Allied armored offensive. And German analysts, reading the reports from North Africa and Italy, continued to believe that American tankers were riding to their deaths in mobile coffins, victims of industrial engineers who had prioritized production over survival. They were not wrong about the dying. American tank crews would die in Shermans by the thousands, burning in vehicles that could not match German guns or German armor. But the Germans had mistaken a cost for a verdict. They had seen the Shermans' weakness and assumed it was the whole story. They had not yet seen the system behind the tank, the factories and depots and recovery vehicles and replacement pipelines that would turn each destroyed Sherman into a temporary absence rather than a permanent loss. That revelation was coming, and when it arrived, it would rewrite everything the Germans thought they understood about armored warfare. August 9th, 1944. A crossroads 2 kilometers south of the village of Saint-Pois in the shattered bocage of Normandy. Oberleutnant Karl-Heinz Decker crouched in a drainage ditch and watched the Americans repair a tank. Decker was not supposed to be here. His reconnaissance patrol, 3 men from the remains of the 116th Panzer Division, had been probing American lines for 2 days, gathering intelligence on enemy dispositions for a counterattack that would never come. They had found a concealed position overlooking an American maintenance area, and what Decker witnessed over the next 4 hours would fundamentally alter his understanding of the war. The Sherman in question had thrown a track during the morning's advance. It sat at an angle in a farm lane, its left track splayed out behind it like a broken limb, the crew standing nearby smoking cigarettes with the casual demeanor of men waiting for a bus. A recovery vehicle arrived within 30 minutes. Decker noted this with professional interest. German recovery vehicles existed, of course, but their availability was limited, their deployment carefully prioritized. A Panther with a thrown track might wait hours or days for recovery, depending on the tactical situation and the availability of assets. The Americans had apparently dispatched a recovery vehicle for a single disabled tank as a matter of routine. What happened next defied everything Decker had been taught about armored vehicle maintenance. The recovery crew, 4 men, none of them appearing older than 25, dismounted and examined the damaged track with an air of bored competence. One of them retrieved a toolkit from the vehicle. Another began working on the track tensioner. A third disappeared beneath the hull to examine the road wheels. "They're going to repair it here," Decker whispered to Feldwebel Braun, his senior NCO, in the field, with a thrown track. Braun, a veteran of 3 years on the Eastern Front, shook his head. "Impossible. A thrown track requires depot maintenance. They'll tow it to the rear." They did not tow it to the rear. In 97 minutes, Decker timed it, scribbling notes in a pocket diary that would later be captured and analyzed by American intelligence. The American maintenance crew repaired the track, replaced 2 damaged road wheels, and had the Sherman moving under its own power. The tank crew remounted, waved at the maintenance team, and drove back toward the front. Decker stared at the empty space where the disabled tank had sat. 97 minutes. A repair that would have taken a German crew most of a day, assuming parts were available, assuming a maintenance unit could be spared, assuming the vehicle wasn't simply abandoned as too costly to recover. "Perhaps we witnessed something unusual," Braun offered. "An exceptional crew, a minor problem." But it was not unusual. Over the next 3 hours, Decker watched the same maintenance area process 2 more damaged Shermans. The first arrived on a flatbed trailer, its turret blackened by fire, a hole punched through the hull where an anti-tank round had penetrated, a killing blow, Decker assumed, a tank destroyed, a crew dead or wounded, a permanent subtraction from American strength. The maintenance crew swarmed it like ants on a carcass. They cut away the damaged hull section with acetylene torches. They welded a patch plate into place. Not an elegant repair, not a factory restoration, but a functional seal that would keep the interior protected from weather and shrapnel. They tested the engine, which apparently still ran. They checked the transmission. They replaced the commander's periscope, shattered by the same impact that had holed the hull. 4 hours and 20 minutes. A tank that German doctrine would have classified as destroyed was rolling out of the maintenance area under its own power, headed for a depot where more extensive repairs would return it to combat readiness. The third Sherman arrived with its engine dead, a mechanical failure, not combat damage. This one, Decker expected, would require evacuation to a rear area facility. Engine replacement was a major operation, requiring hoists and specialized equipment and hours of labor. The Americans replaced the engine in the field. Decker watched, barely breathing, as a crane mounted on a recovery vehicle lifted the entire rear deck off the Sherman, exposing the engine compartment like a surgeon opening a patient's chest. The dead engine came out in a single unit, a replacement engine sitting on a pallet that had apparently been waiting for exactly this purpose, went in. Hoses connected, cables attached. The deck went back on. 3 hours and 41 minutes. An engine replacement that would have immobilized a Panther for a week, assuming spare engines were available, which they increasingly were not, had been accomplished by 5 men with a truck-mounted crane and a replacement power plant that seemed to have materialized from nowhere. Mein Gott, Braun breathed. They have spare engines, just sitting here, waiting. Decker was performing calculations he did not want to complete. German armored units in Normandy were reporting operational readiness rates below 40%. Not from combat losses, but from mechanical breakdown and lack of parts. Transmissions failed and could not be replaced. Engines wore out and sat waiting for rebuilds that never came. Track links snapped and entire vehicles were abandoned because no replacement links existed within 100 kilometers. The Americans had spare engines on pallets. They had road wheels stacked in crates. They had track links by the thousands, transmissions in warehouses, every component of the Sherman available in quantities that seemed designed for a war 10 times the size of this one. Decker thought about the Kummersdorf report, which he had read in summary form during his officer training, the famous assessment of the captured Sherman: armor inadequate, armament inferior, automotive components crude. The conclusion that the Sherman posed no threat requiring a response. The engineers had measured armor thickness. They had not measured the speed at which Americans could repair a penetrated hull. They had measured gun caliber. They had not measured the availability of replacement gun tubes. They had measured engine horsepower. They had not measured the existence of spare engines staged forward, waiting for installation. They had measured the tank. They had not measured the system. And in that failure of measurement, Decker now understood, lay the seed of Germany's defeat. He withdrew his patrol as darkness fell, carrying notes that would never reach German intelligence. His unit would be overrun 3 days later, and Decker himself would spend the rest of the war in an American POW camp. But the understanding he had gained in that drainage ditch stayed with him for the rest of his life. "We asked the wrong question," he would tell an interviewer in 1978. "We asked, which tank is better? The Panther was better. The Tiger was better. By every measurement that German engineers considered important, our tanks were superior. But the Americans were not trying to build a better tank. They were trying to build a better army. And a better army is not the one with the best tanks. It is the one with the most working tanks." At any given moment, on any given day, the Americans had more working tanks than we did. Not because they built more, although they did, but because they kept them working. We built magnificent machines that broke down and could not be repaired. They built adequate machines that broke down and were repaired in hours. In a war of days, our approach might have won. In a war of years, theirs was the only approach that could win. He paused, the interviewer noted, and lit a cigarette with hands that trembled slightly. Not from age, but from memory. "I watched them replace an engine in 3 hours and 41 minutes. I have never forgotten that number. 3 hours and 41 minutes. Our engineers at Kummersdorf spent weeks measuring armor thickness and muzzle velocity. They should have sent a man with a stopwatch to time American repairs. That number, 3 hours and 41 minutes, would have told them more about why we were going to lose than all their penetration tables and ballistic calculations combined. The turning point was not a battle. It was not a victory or a defeat. It was a realization, spreading through German ranks in 1,000 small moments like the one Decker witnessed, that they were fighting an enemy who had optimized for a different kind of war. The Germans had built tanks to win engagements. The Americans had built tanks to win campaigns. And campaigns, it turned out, were what mattered. The autumn of 1944 became a masterclass in the mathematics of attrition. German panzer divisions, bled white in Normandy and the Falaise pocket, retreated eastward through France with their strength measured not in tanks but in ghosts. The 2nd Panzer Division, which had crossed into France in June with 94 operational tanks, reached the German border in September with 9. The Panzer Lehr Division, elite of the elite, could field 12 tanks from an original complement of over 200. The 116th Panzer Division reported 16 operational vehicles. The remnants were magnificent machines, Panthers and Tigers, surviving by skill and luck through 3 months of continuous combat. Their crews were veterans who had killed dozens of Shermans, who had validated every assessment in Hasselmann's Kummersdorf report. They had proven, beyond any statistical doubt, that German tanks were superior. And they were losing. General Lieutenant Heinrich von Luttwitz, commanding the 47th Panzer Corps, filed a situation report on September 17th that captured the impossible contradiction. Tactical performance of panzer units remains excellent. Kill ratios against American armor consistently exceed 3-1, in many engagements approaching 5-1. Despite this, operational tank strength continues to decline. Losses to mechanical failure now exceed combat losses. Replacement vehicles are not arriving. Spare parts are unavailable. We are winning every battle and losing the campaign. The report included a statistical appendix that read like an autopsy. Of 47 tanks lost by the 47th Panzer Corps in the first 2 weeks of September, only 19 had been destroyed by enemy action. The remaining 28 had been lost to mechanical failure. Engines that seized, transmissions that shattered, final drives that stripped their gears, and abandoned for lack of recovery assets or spare parts. Each abandoned tank represented not just lost equipment, but lost expertise. Crews who had survived months of combat, now walking infantry, their irreplaceable skills wasted. Meanwhile, American tank strength was growing. Major Wilhelm Kessler, an intelligence officer attached to Army Group B, compiled weekly estimates of American armored strength that he could not bring himself to believe. His reports, preserved in captured documents, show a man confronting impossibility. September 3rd. First U.S. Army estimated operational tank strength, 1,847 medium tanks. This represents an increase of 234 tanks since August 15th, despite estimated combat losses of 380-plus tanks in the same period. September 10th, revised estimate, 2,106 medium tanks, increase of 259 tanks in 1 week. Sources indicate continued arrival of replacement vehicles and return of repaired tanks from depot facilities. American tank strength now exceeds D-Day levels. September 17th, estimate suspended pending methodology review. Current figures suggest American tank strength is increasing at a rate that exceeds our ability to destroy them. This contradicts all established models of attritional warfare. Request guidance. No guidance came. There was no guidance to give. The models were not wrong. The assumptions underlying the models were wrong. German doctrine assumed that destroyed tanks were permanent losses. American doctrine had made destroyed tanks into temporary inconveniences. The disparity became undeniable as German units encountered Shermans they had already killed. Feldwebel Otto Brenner, a gunner in a Panther of the 9th Panzer Division, described an engagement near Aachen in October 1944 that exemplified the phenomenon. We held a position covering a road junction. Good fields of fire, perhaps 800 meters. In the morning, an American column approached, 12 Shermans. We destroyed 7 in the first engagement. Perfect shooting. The commander logged the kills with our radio operator. 7 confirmed. He lit a cigarette, the interviewer noted, and his hands were steady, but his voice was not. That afternoon, the Americans attacked again. Same road, same approach. I counted through my gun sight as they came. 12 Shermans, the same tactical markings as the morning, the same unit. 12 tanks, 5 hours after we had destroyed 7 of them. Brenner inhaled deeply. I said to my commander, "Where did they get 5 tanks in 5 hours?" He had no answer. We engaged. We destroyed 4 more. They withdrew. The next morning they came again. 12 tanks, the same markings. 12 tanks. He crushed out his cigarette. We were killing them faster than any panzer crew in the division. Our kill count was magnificent, and every day there were more of them. Every day the 12 came back. I began to wonder if we were killing anything at all, or if we were simply delaying them, inconveniencing them. You cannot win a war by inconveniencing the enemy. The recovery and repair system that Gladian Barnes had designed was operating at full capacity and exceeding its design parameters. Rear area depots processed damaged tanks on a 24-hour cycle. Vehicles that arrived in the morning were assessed, categorized, and either repaired on-site or stripped for parts by nightfall. A Sherman with repairable damage could return to its unit within a week. A Sherman with extensive damage could be rebuilt from components and returned within a month. Only catastrophic destruction, a complete hull breach, an ammunition explosion that gutted the interior, removed a tank permanently from the system. And even catastrophic losses fed the machine. A destroyed Sherman yielded road wheels for 3 damaged Shermans. Its transmission could be rebuilt and installed in another vehicle. Its gun, if intact, could replace a worn tube. The Americans wasted nothing. They could not afford to waste anything, and so they had built a system that wasted nothing. The Germans, by contrast, were bleeding parts they could not replace. Major Hans Kramer, a maintenance officer with the 11th Panzer Division, kept a diary that documented the collapse in real time. October 3rd, 14 Panthers operational this morning. Engine failure on 324 during road march, no replacement available. Track failure on 318, no spare links. 11 Panthers operational by evening, no combat. October 7th, Tiger 231 requires transmission rebuild. Estimated time with available resources, 3 weeks. Crew reassigned to infantry duties. 10 Panthers operational. 2 lost to enemy action today. Good kills, flank shots at close range, but we cannot replace them. October 14th. Received authorization to cannibalize 324 for parts. Recovered engine, transmission, road wheels. Enough to repair 318 and 312. 12 Panthers operational, but 324 is now a hulk. We are eating ourselves. October 21st. 6 Panthers operational. I have submitted 14 requisitions for spare parts in the past month. None have been fulfilled. The supply officer tells me that factories are producing, but transportation is impossible. Allied air attacks have destroyed the rail network. Parts exist. They simply cannot reach us. Meanwhile, I watch American supply convoys drive past on the horizon, headlights blazing at night, as if they do not know what concealment means. Perhaps they do not need concealment. Perhaps they have so much that they can afford to be seen. The headlights became a symbol. German soldiers, trained from their first day in uniform to conceal movement, to travel at night with blackout discipline, to assume that any light would draw artillery fire or air attack, watched American convoys roll through France with their headlights on. Not occasionally, not carelessly, deliberately, as a matter of policy, because the Americans had so many trucks, so many tanks, so many replacements that the risk of losing a few to air attack was acceptable. Hauptmann Victor Linz, a company commander in the 10th Panzer Grenadier Division, wrote to his wife about the headlights in November 1944. You cannot imagine it, an endless ribbon of light stretching to the horizon. We watch from our positions and count the vehicles. We stop counting at 100, 200. They are still coming, every night, every single night, and our fuel ration for the week would not move our battalion 5 kilometers. I think about the engineers who designed their tanks. Our engineers at home, I have read, considered the Sherman inferior. Perhaps they were right about the armor. Perhaps they were right about the gun. But did they measure this? Did they measure the endless ribbon of light? Did they measure the fact that the Americans have so many vehicles they can drive with their headlights on, while we husband every liter of fuel as if it were blood? They measured the wrong things, Liesel. They measured metal and explosives. They should have measured excess. The Americans have excess of everything. We have excess of nothing. This is why we are losing, not because their tanks are better, because they have more of them than we can ever destroy. The psychological toll accumulated like compound interest. German tank crews who had begun the campaign confident in their technical superiority found that confidence eroding with each engagement. They could kill Shermans, they proved it daily, but the Shermans kept coming. They could win battles, they won most of them, but the battles didn't stay won. The enemy they had destroyed in the morning returned in the afternoon, fresh and whole and apparently inexhaustible. Unteroffizier Werner Kolb, a driver in a Panther that had survived from Normandy to the German border, expressed the growing despair in a letter censored but preserved in unit files. We are the best tank crews in the world. Everyone says this. Our training, our experience, our machines, all superior. I have seen Hauptmann Ritter destroy 4 Shermans in a single engagement. Beautiful shooting, each one burning before the next was even identified. We cheered as if we had won something. But what did we win? The next day, there were more Shermans. There are always more Shermans. We kill them, and they multiply. I am beginning to believe that we cannot kill enough of them. Not because we are not good enough. Because there is no enough. There is no number we can reach that will make them stop coming. They are not fighting to win battles. They are fighting to outlast us. And they have more time, more tanks, more everything than we will ever have. The engineers who built our Panther built a masterpiece. I believe this. But I am beginning to wonder if the engineers who built the Sherman understood something our engineers did not. Perhaps they did not try to build a masterpiece. Perhaps they tried to build something else, something that could not be exhausted. And perhaps, in a war like this one, that is worth more than any masterpiece. The Wehrmacht had spent 3 years proving that quality defeated quantity. In the autumn of 1944, they were learning that this was only true when quantity had limits. American quantity did not have limits. American quantity was a river that flowed from factories 3,000 miles away, through depots and ports and maintenance bays, and emerged on the battlefield as an endless procession of Shermans, each one identical, each one replaceable, each one part of a system that the finest tank in the world could not defeat. The Kummersdorf engineers had measured armor thickness. They had not measured the river, And now, the river was drowning them. The final accounting told a story that no German technical report had anticipated. Between June 1944 and May 1945, American forces in the European theater lost 4,295 M4 Sherman tanks to enemy action. An additional 7,466 were damaged severely enough to require evacuation to rear area repair facilities. Total tanks removed from frontline service, 11,761. By every metric German engineers had used to evaluate armored warfare, this should have represented a catastrophic defeat. 11,000 tanks destroyed or damaged, entire armored divisions worth of equipment, burning in the fields of France and Belgium and Germany. A vindication of Hasselmann's assessment, of Berger's lectures, of every report that had concluded the Sherman was inadequate for modern armored combat. But the final accounting told a different story. Of those 7,466 tanks evacuated for repair, 6,197 returned to combat, not as spare parts, not as stripped hulks, as operational tanks, rebuilt and restored and sent back to the front. An 83% recovery rate. Vehicles that German gunners had destroyed, that German intelligence had counted as permanent kills, rolled back into battle weeks or sometimes days later. The depot system processed this flood with mechanical efficiency. The facility at Cherbourg alone returned 2,847 tanks to service, more tanks than the entire German panzer force in the West possessed at any point after D-Day. The depot at Liège, established after the liberation of Belgium, processed another 1,940. Smaller facilities scattered across France and Belgium handled thousands more. And the factories never stopped. Between June 1944 and May 1945, American plants produced 17,614 new M4 Shermans, 17,000 tanks, enough to replace every loss 3 times over, enough to equip entire new armored divisions, enough to send to the Soviet Union under Lend-Lease while still maintaining overwhelming superiority in the West. The mathematics German engineers had believed were irrefutable had been refuted by a system they never measured. Kill ratios meant nothing when the killed refused to stay dead. Combat superiority meant nothing when the superior vehicle sat immobilized for want of a transmission. Tactical victories meant nothing when the enemy could absorb 10 tactical defeats and still have more tanks at the end of the month than at the beginning. The men who had designed and built and evaluated German tanks were forced to confront this reality in interrogation rooms and prison camps across occupied Germany. Diplom engineer Friedrich Hasselmann, the man who had examined the first captured Sherman at Kummersdorf, who had written the 47-page report concluding that the vehicle posed no threat requiring response, was interrogated by American technical intelligence officers in June 1945. The transcript of that interrogation, classified for 30 years and released in 1975, reveals a man whose professional certainties had been systematically demolished. I was asked to evaluate a tank, Hasselmann told his interrogators. I evaluated it as I had been trained to evaluate tanks. Armor thickness, gun performance, automotive specifications. By every metric I measured, the Sherman was inferior to our vehicles. I stand by those measurements. They were accurate. He paused, the transcript notes, and removed his glasses to polish them. But I measured the wrong things. I measured the tank as a weapon. I should have measured it as a component in a system. The Americans did not design the Sherman to defeat the Panther in single combat. They designed it to be manufactured, shipped, maintained, repaired, and replaced at rates we could not match. They designed it to fight a war of years, not a war of battles. And in a war of years, their design was superior. Not because it was a better tank, because it was a better answer to the problem of mechanized warfare. The interrogator pressed him. If you had understood this in 1943, would your recommendations have changed? Hasselmann's response was quiet. I do not know what I would have recommended. We could not have built a Sherman. Our industrial philosophy, our engineering culture, our entire approach to weapons development, all of it was oriented toward building the best possible weapon, not the most sustainable system. To build what the Americans built would have required us to become Americans. And we were Germans. We built masterpieces. They built tools. Their tools won. Professor Ferdinand Porsche, whose engineering bureau had produced the Tiger tank and who had dismissed the Sherman as a Ford with a cannon, was interviewed by Allied investigators in August 1945. His assessment, stripped of the confidence that had characterized his wartime pronouncements, acknowledged a fundamental miscalculation. We asked, what is the best tank we can build? The Americans asked, what is the best tank system we can build? These are different questions. They produce different answers. We built vehicles that were superior in combat, but impossible to sustain in a long war. They built vehicles that were inferior in combat, but inexhaustible in a long war. We assumed the war would be decided by combat. The war was decided by exhaustion. Their assumption was correct. Ours was wrong. Portia lit a cigar, the interviewer noted, and stared out the window at the rubble of what had been Germany's industrial heartland. I have spent 40 years designing machines. I believed I understood what machines were for. The Americans taught me that I understood only half of the problem. A machine that cannot be sustained is not a machine. It is a monument. We built monuments. They built machines. Perhaps the most comprehensive admission came from Generaloberst Heinz Guderian himself, the father of German armored doctrine, the architect of Blitzkrieg, the man whose theories had revolutionized warfare in 1940. Guderian was interrogated extensively by American and British intelligence officers between May 1945 and his release in 1948. In one session, dated November 1945, he was asked directly about the Sherman tank and German assessments of its capabilities. Our technical evaluations were accurate, Guderian said. The Sherman could not defeat the Panther or Tiger in a direct engagement. This was demonstrated repeatedly in combat. Our kill ratios were excellent. If the war had been decided by kill ratios, we would have won. He shifted in his chair, the transcript notes, and his voice hardened. But wars are not decided by kill ratios. Wars are decided by which side has operational vehicles on the battlefield at the end of each day, by which side can replace losses faster than they are inflicted, by which side can sustain operations over months and years without exhausting its capacity to fight. In all of these metrics, the metrics that actually determine victory, the Americans were superior, not slightly superior, overwhelmingly superior, decisively superior. The interrogator asked, why did German planners not anticipate this? Guderian's answer cut to the heart of the failure. Because we measured what we valued, and we valued the wrong things. We valued engineering excellence. We valued combat performance. We valued the ability to destroy the enemy. These are warrior values. They are not wrong, but they are incomplete. The Americans valued something else, the ability to continue, to absorb losses and keep fighting, to treat destroyed tanks not as tragedies but as temporary setbacks, to build a system so deep, so resilient, so inexhaustible that no amount of tactical excellence could defeat it. He paused, and when he continued, his voice was barely audible. We built the best tanks in the world. The Americans built the best army in the world. In the end, armies win wars. Tanks do not. This is what we failed to understand. This is why we lost. The interrogation files accumulated. Hundreds of German officers and engineers, each contributing a fragment to the mosaic of comprehension, each admitting, in their own way, that the framework they had used to evaluate American armor had been fundamentally flawed. Oberst Werner Kruger, who had attended Hasselmann's original presentation at Kummersdorf, who had nodded with satisfaction at the conclusion that the Sherman posed no threat, was interviewed in September 1945. I watched the original examination. I read the report. I agreed with every word. The Sherman was inferior by every measure we applied. We did not apply enough measures. We did not measure maintainability. We did not measure replaceability. We did not measure the depth of the American logistics system. We measured the tank as if it existed in isolation, as if it would fight alone, as if the war would be decided in single engagements. The Americans understood that the tank did not exist in isolation. It existed within a system, and their system was better than ours. He fell silent for a moment before adding, "We were very good at building tanks. We were very poor at building systems. The Americans were adequate at building tanks and magnificent at building systems. Adequate systems with magnificent tanks lose wars. Magnificent systems with adequate tanks win them. This is the lesson of 1944. I do not know if we are capable of learning it." The lesson was clear. The admissions were comprehensive. The evidence was overwhelming. German engineers had examined the Sherman with meticulous precision. They had measured every dimension, analyzed every alloy, calculated every ballistic coefficient. Their work was thorough, professional, and technically unimpeachable. And it had missed entirely the thing that mattered most. The Sherman was not a tank. It was a philosophy that understood war as a problem of industrial endurance rather than tactical excellence. The Germans had built weapons to win battles. The Americans had built systems to win wars. The systems had won. On the morning of March 17, 1943, Diplom Ingenieur Friedrich Hasselmann had walked slowly around a captured M4 Sherman and permitted himself a thin smile of professional contempt. He had measured the armor, 51 millimeters, inadequate against German guns. He had measured the gun, 75 millimeters, insufficient against German armor. He had measured the engine, the transmission, the suspension, every component that German engineering doctrine held meaningful. He had filed a 47-page report concluding that the Sherman posed no threat requiring response. His measurements had been perfect. His conclusion had been catastrophically wrong. Hasselmann survived the war. He was denazified, cleared of significant involvement with the regime, and returned to engineering work in the civilian sector. He spent the rest of his career designing industrial machinery for the reconstructed German economy, conveyors and presses and assembly line equipment, the unglamorous infrastructure of manufacturing. In 1972, he was interviewed by a German military history journal preparing a retrospective on Wehrmacht technical intelligence. The interviewer asked him about the Kummersdorf examination, about the report that had shaped German perceptions of American armor for the critical years of 1943 and 1944. Hasselmann was 78 years old. His hands trembled slightly as he held the faded copy of his own report, its pages yellowed, its confident conclusions preserved like insects in amber. "I have read this document perhaps 100 times since the war," he said. "Each time I search for the error. Each time I find no error. The measurements are correct. The calculations are sound. The analysis follows logically from the premises." He set the report down on the table between them. "The premises were wrong. That is not the same as making an error. An error can be corrected. Wrong premises must be unlearned. And unlearning is the hardest thing a professional can do." The interviewer asked what he would have done differently. Hasselmann was quiet for a long moment. "I would have asked different questions. I asked, how thick is the armor? I should have asked, how quickly can this armor be manufactured? I asked, how powerful is the gun? I should have asked, how many of these guns exist in warehouses, waiting to replace worn tubes? I asked, how sophisticated is the transmission? I should have asked, can a mechanic repair this transmission in a field with basic tools in hours rather than days?" He gestured at the report. "Every question I asked was a question about the tank. I should have asked questions about the war. What kind of war were the Americans preparing to fight? What did their design choices reveal about their assumptions? They had built a tank that sacrificed combat performance for manufacturability, that sacrificed sophistication for repairability, that sacrificed individual excellence for systemic resilience. Why? What did they know that we did not?" He shook his head slowly. "They knew the war would be long. They knew it would be fought across oceans at the end of supply lines stretching thousands of kilometers. They knew that a tank destroyed in France could not be replaced from a factory in Detroit unless the tank was designed, from the beginning, to be replaced. They knew that the best tank in a single battle is worthless if it cannot fight 100 battles. They designed for 100 battles. We designed for one." The interviewer pressed, did he feel responsible for the German failure to anticipate American capabilities? Hasselmann's answer was careful. "I was one engineer among many. My report was one document among thousands. The failure was not individual, it was institutional. We built an entire system of evaluation around the wrong questions: armor thickness, penetration values, muzzle velocity. These were the metrics we taught our officers to value, our engineers to measure, our factories to optimize. No single report could have changed this culture. The failure was in the culture itself." He picked up the report one final time, holding it as if weighing something heavier than paper. "But I will say this. I was there, at the beginning. I held that Sherman's armor in my hands and pronounced it inadequate. I was right about the armor. I was wrong about everything else. And everything else was what decided the war." Hasselmann died in 1979. His obituary in the Frankfurter Allgemeine Zeitung mentioned his wartime service only briefly. A few lines about technical intelligence work, nothing about the Kummersdorf report, or the Sherman, or the 47 pages that had shaped German doctrine. He was remembered as a competent industrial engineer who had contributed to Germany's post-war economic miracle. But among military historians, among the scholars who studied the intersection of technology and strategy, Friedrich Hasselmann became a cautionary figure, not a villain, not a fool, but something more instructive, a highly competent professional who had applied his competence to the wrong problem. He had measured what he had been trained to measure. He had evaluated what his framework equipped him to evaluate. He had reached conclusions that followed logically from his premises. His premises had been wrong. The Sherman tank, the vehicle Hasselmann had dismissed as a mediocre design built by industrial engineers rather than weapons engineers, went on to become the most important armored vehicle of the Second World War. Not because it was the best tank, it was not. German tanks were better armored, better armed, better engineered by every metric that Hasselmann and his colleagues had considered meaningful. The Sherman was the most important tank because it was enough armor to survive some hits, enough firepower to achieve some kills, enough reliability to keep running when German tanks broke down, enough simplicity to be repaired by mechanics trained on trucks, enough standardization to be manufactured by automobile factories, shipped across oceans, and rebuilt from components in forward depots. Enough to win. The lesson of the Sherman was not that quality doesn't matter. Quality matters. German tanks killed Shermans at rates that would have been decisive in a shorter war, a smaller war, a war fought on a single continent with intact supply lines and unlimited time. The lesson was that quality is not the only thing that matters, and in a war of attrition, a war of endurance, a war fought across oceans and years, it may not be the thing that matters most. Gladian Barnes, the American engineer who had shaped the Sherman's design philosophy, died in 1961. Unlike Hasselmann, he left no recorded reflections on his work, but his design choices spoke for themselves, encoded in the specifications of a tank that had been built not to win battles, but to win wars. Barnes had understood something that German engineers, for all their brilliance, had failed to grasp, that a weapon is not an object, but a process. The tank in the factory, and the tank in the field, and the tank in the repair depot, and the tank returning to combat are all the same tank, different phases of a continuous cycle. To design only for combat is to design for a single phase. To design for the entire cycle is to design for victory. The Germans had designed magnificent weapons. The Americans had designed a magnificent process. In the spring of 1943, Hasselmann had measured a Sherman's armor and found it wanting. He had not measured the factories that could produce that armor by the 1,000 tons. He had not measured the ships that could carry it across the Atlantic. He had not measured the depots that could weld it back together after German guns had torn it apart. He had not measured the system that could take a destroyed tank and return it to battle while German tanks sat immobilized, waiting for parts that would never come. He had measured the Sherman against the Panther. He should have measured the Sherman against the war. The Panther was the better tank. The Sherman was the better answer. And in the end, answers are what matter. Not elegance, not sophistication, not the clean lines of engineering excellence, but the brutal, practical, unsentimental question. Does this solve the problem? The problem was winning a global war of attrition against enemies fighting on two fronts across two oceans. The Sherman solved the problem. 47 pages of precise German analysis had concluded otherwise. The 47 pages were wrong.